issues as far as my office hours. All right, we'll set up from current slide, and I'll even turn on the projector for you today. I'm just feeling magnanimous. Okay. Couple of things. Let me hit my office hours first. Okay. Normally today, on Tuesdays and Thursdays, I have office hours from 10:45 to 12:30. However, I'm taking my physical science class this afternoon on a field trip, so I've got to go to the Birmingham campus, get the vehicle, and bring it back. So I'll be leaving shortly after 10:45 class gets over with, hopefully get to the Birmingham campus somewhere around 11:15. Hopefully the checkout will not be too slow, and hopefully I'll get back here 11:45 to 12 o'clock. Don't know if everything will go that smoothly, but that's what I'm hoping for. Okay, so my office hours are cut from 10:45 to 12:30 to something like 12 to 12:30. Okay, so if you're looking for me, hang on. If it's any time around 11:45 or 12, I should be back soon, hopefully. Okay? Then my class takes up the rest of the afternoon, except we go on the field trip, we come back, I give them the final exam. I'm guessing, and this is just a guess, they'll be through by 4 o'clock. Okay? If so, then I'll have additional office hours from 4 to 5:15. But I don't know. I can't guarantee they'll be through that soon, but I'm thinking they might be. So, that's adjustments to office hours today. Tomorrow, normally I have office hours on the Birmingham campus, 7:45 to 1 o'clock. However, tomorrow I have my annual physical that was scheduled months ago. Actually, it was scheduled much further back, and they had me scheduled for a weekday, not Friday. I said I can't come in the middle of the day because I teach classes, so they moved me to Friday, but this is the earliest one they could give me. So anyway, tomorrow I will be at Perkin Clinic by 7:45, not on Birmingham campus, and Ashley's here, and Nathan's here. Well, I know you're in the class somewhere. I'll take a picture yet. There we go. All right. And yeah, both of them here. I was going to think you're going to make me choose which one of you came today, but both of you did. Yeah. Both Alexis and Allison are here. All right. Just going over office hours. My office hours tomorrow are shortened because I've got my annual physical. However, I hope it's going to be over with by 9, meaning hopefully I'll be back on Birmingham campus by 9:45 or 10. So my office hours normally 7:45 to 1. Tomorrow they'll be more like 10 to 1. But I will be there tomorrow, but it won't be 7:45. It won't be 8. It won't be 9. Sometime after that, around 9:45 or so, 10 o'clock, something like that, I'll be back on campus. All right. Now, that's for this week. Next week, as far as I know, office hours are fine, but I do want to let you know this. This week is the end of first mini-term. Okay? Next week is the beginning of second mini-term. I mean, somewhere over the weekend is midterm. Okay? We just have passed midterm, and or will be passed. We are not yet, but close to it. Next week, they have on the academic calendar that we're supposed to submit the midterm progress reports. And you might say, what in the world is that? That's when we report any students who has a D or an F at midterm so that someone can get in touch with them for counseling, advising, tutoring, whatever it is that needs to try to keep people from being unsuccessful in a course. So what that means for you, and I think I'm preaching to the choir here, if you have turned in a paper, and 4 of you have, congratulations, then you've got a score. If you turned in the first quiz, and most of you, I'm guessing just about all of you have, maybe not all of you, but I see 1, 2, 3, 4, 5, 6, 7 of the 20 students have not turned in the first quiz, which of course means you haven't taken the first test either. So the vast majority of those students, I'm guessing, have no score. And if you have no score and they ask for midterm progress reports, now here's a little inside secret. Sometimes they forget to ask, okay? If they ask, we report. If they don't ask, I don't bother, okay? But if they do ask, then I'll have to report students who have no score as failing at midterm. That doesn't really hurt you any as long as you get stuff in. But to keep me from having to do it, get something in. You got this weekend to work on it, so get your papers done, get your quizzes done, and come see me either today. I don't have a lot of office hours today. Tomorrow, I don't have a lot of office hours tomorrow, or sometime next week, and either finish your test or take your test, okay, if you have turned in the quiz. Remember, you do have to turn in the quiz before you can take the test. And I was just really surprised Tuesday when students were taking the test. I saw hardly anybody who had a formula and equation sheet. Now, I'm not saying no one did, but you can have a formula and equation sheet when you're taking your test. I had announced it in class. I announced it the first of the term, but I saw a precious few. And unfortunately, it looks like some of the grades indicated you didn't have that or do that. All right. Any questions? I can't think of any other announcements. Just wanted to bring you up to date. Okay, if no questions, we are picking up where we left off last time. We moved into Chapter 2, Section 2.1, and we had done Example 1. Just a quick reminder of Example 1. It was sketching a parabola, the parent parabola, okay, parent function, and then two adjustments to that, okay? So today we're picking up, focusing on that. In Example 1, note that the coefficient of that parabola determines how wide or how narrow that parabola opens. F of x equals ax squared. So what do you think? What A will make a wide parabola? Second? Okay, not quite. A whole number greater than 1 will make a skinny parabola. In other words, for every x value, your f of x is now larger. So that's going to stretch it upward. If the A is between 0 and 1, that widens it. If it's 1, it's like this. If it's between 0 and 1, it does like this. If it's greater than 1, it pulls it up like this. Okay? Make sense? Okay. Now, notice I didn't say anything about the sign of A. I said if A is positive. Okay? So here's what I just said. When the absolute value of A is small, the parabola opens wider than when the absolute value of A is large, as in greater than 1. So we know that the graphs, okay, need to have a new slide or a new paragraph or something here. Here's something else we know. Now, what determines which direction it opens, up or down? Yes, the sign of A. If A is a positive number, it's opening upward, whether it's a small positive number or a large positive number, it's opening upward. If A is negative, a small negative number is opening downward. A large negative number is also opening downward. So, new paragraph, new concept. We know that the graphs of y is equal to f of x plus or minus c. What is that going to do? What does a graph like that do? What does that c do for you? Does what? X-intercept. Yeah. It adjusts the x's. Amber Jones is here. Okay. And on top of all my announcements I was making before, I forgot to say this one. A lot of people, in fact, all but maybe one or two, indicated they weren't finished, or either indicated they weren't finished, or I couldn't tell if you were finished or not, okay, with the test from last Tuesday. So if you were planning to come back and make it up, you need to do it sometime during my office hours. I was just explaining to the people earlier, my office hours are fairly short today because I've got to go to the Birmingham campus and pick up a van this morning after my 10:45 class, but I should be back in the office by 12, hopefully by 12, and if I am, you can start working on your continuing on the test then, or starting on the test then, if that shoe fits. I know you're in here. Tyrell, there you are. Okay. Oh, okay. Okay. But, and I was also telling people this, I should be back from the field trip, I'm guessing around 2:45 or 3 o'clock. Then that class is going to be taking their final exam. We'll be down in room 261 after 3 o'clock, 261. We may not be back right at 3, but we'll be there sometime 3-ish or a little after 3. And as long as there's room in the class, and there's only 14 students and 14 in that class, so there's plenty of desks or a few seats available, but there's plenty of empty rooms around there at that time. You can come take your test then. They'll probably be through their test 4:15, 4:30. It's not a long test. So I'll be back in the office after that, and you can take your test. I will have to leave today no later than 5:15. Most days I have flexibility there. Last night I was here considerably after 5:15, but tonight I've got to leave by 5:15. So you can start making up your test then. If you're coming to the Birmingham campus tomorrow and want to make up your test, let me know so I'll carry your test or a test with me so I have it with me. But remember, I will not be there. I can't say what time I'll get there, but it's going to be around 10-ish, maybe 9:45, maybe a little after 10, somewhere around 10. I'll only be there till around 1-ish or so. I can stay later tomorrow if people are there. So if you haven't started or finished your test, please try to get that done within a week, please. All right, what we're saying here, the graphs of y is equal to f of x plus or minus c. This is a horizontal shift because it's moving it, a rigid transformation, moving it to the left or right. Okay? Remember, with anything to do with x, it's always opposite. The plus goes to the left, the minus goes to the right. Okay? What is this one? F of x plus or minus c. A vertical shift, because this is your y value, and it's going either up or down, and that goes according to the sign. Up is positive, down is negative. What does f of minus x do? What does it do? Okay. What does the f of minus x do? It what? You may have said it. I can't hear it. What? No. This one moves it right or left. This one reflects it across the y-axis. Okay, because it's negating the x. So if it was over here, it comes over there. If it was over here, it goes over there. And what does this do? Reflects it across the x-axis because you're negating the y. What was up here goes down here. What was down here goes up here. Okay. Quick review of our transformations. Now, these are all rigid transformations. Those were non-rigid transformations. These are your rigid transformations. The shifts and the reflections, okay, of the graph of y is equal to f of x. Okay. Now, in these figures below, notice how the graph of y is equal to f of x, which is the gray graph here, okay, in either case, can be transformed to produce the graphs of, this would be negative x squared plus 1. What does the negative do? Flips it across the x-axis, so that reflects it here, then the plus 1 shifts it up. So this, the first is a reflection, and this is a transformation, a vertical shift. Okay? What does this one do? Down 3 and 2 to the left. Sure enough, this graph has shifted down here. No reflections in that one because there's no minus in front of the x, but there is both a horizontal and a vertical shift. Make sense? Both of these are rigid transformations. All right. Now, there is a reason they're doing that and talking about it but they don't make it really clear. Okay? So sort of keep this in mind. I'll come back and show you why they brought this up at this point. And this is why. The standard form of a quadratic function. I can almost hear you now if I said, what's the standard form for a quadratic function? Would any of you have a guess? No. Okay. Say again? Okay, you're getting pretty close to it. Okay, what were you going to say? Well, it didn't do it. Okay. You said y minus y1. M times x minus x1. Okay? Anyone know what that is called? Say again?
What were you asking for?
I asked for a standard form of a quadratic equation there in big print. That's not it. What is that called? That is a nice form. What is that form? It's a what? That's for a linear equation. X is only raised to the first power. And here you have a, what's that? This is a point. It's a point slope form for a linear equation. Not quite what a standard form for a quadratic equation is. Now, I'm going to write something down and you tell me if this is the standard form for a quadratic function. Okay? Ax squared plus bx plus c equals 0. Does that look familiar? Would you say that's the standard form for a quadratic function? Not quite. That's the standard form for a quadratic equation, not necessarily a quadratic function. So the reason I say this is, and maybe saying it is going to make it more confusing, but this is the standard form for a quadratic equation, because this is the form we use when we use the quadratic formula, all that kind of stuff. That's solving an equation. Not quite the same thing of writing a function. Okay? So, let's go right to it. The standard form for a quadratic function is this. It has an a. And guess what, folks? It's the same a as what I just wrote down in the previous one. But instead of a BC, it has an HK. Why would they do that? Okay. Let's go back. Actually, Jonathan's a plant here. He doesn't know it. Is this the handiest form for a linear equation? Yeah, it gives you the slope, and it gives you a point. Okay? And actually, in that equation, you can plot the exact curve there, but it's a little long and harder to remember. What would you say the easiest form for a linear equation would be? Y is equal to mx plus b. Why? Here, and by the way, time out before you answer that. Here is what many books call the standard form for a linear equation. Now, I don't like calling it that, but they do. They call that the standard form for a linear equation. And it is a perfectly good form for a linear equation. And it may be standard to some people. But what does the A, B, and the C tell you? They're just coefficients. They don't help you plot the function at all. You can't draw the graph from that form. The only thing you can tell from this, if C is negative, you know it's going through the origin. That's all, folks. If C is not negative, it's not going through the origin. That's all that form tells you. Whereas what does this form tell you? That gives you the slope and the y-intercept. You find the y-intercept and then use the slope. You can graph the whole function just by looking at that form. Pretty nice, huh? This doesn't do it. That's called the standard form. That is the most useful form. Now this one's pretty useful too, but it's a little longer and more involved. You have to remember where to put what. But if you have a point and the slope, you can go from there too. Just like you can there, this is just a simple form. Here all you do is solve for y. just solve for y is what we usually are used to doing anyway, okay? So, here's the deal. If you took out the equation part here, okay, and put in function notation, that is a form, that is a perfectly good expression for a quadratic function, for sure, okay? But of these things, what does the B and C tell you? Absolutely nothing. The A tells you something, but it doesn't, you can't graph the function from this until you fiddle with it. So that's why we use this form. F of x is equal to A, that same A we had before that tells you something, x minus h squared plus k. Now, remember this? This technically is in standard form. The A here is a minus 1. Okay? That means it's opening downward. That's all that means. It's opening downward and not too wide or not too skinny. That's what that tells you. The H here is 0. Okay? If you go back to that form, the H is 0. That means okay. And the K is 1. Well, what you reckon 0, 1 is here? 0. Oh, look at that. It's the vertex. So this form, this standard form, tells you vertex, HK, and tells you how wide it is. It tells you direction it's opening and also how wide it's opening. That's what the A tells you. This one here, that's in standard form. What does this tell you? Going upward, and it's going up at the standard form, no stretching or shrinking. Okay, what does this tell you? Left 2, down 3, so -2, -3 is the vertex. Yes, this is a very useful form because it lets you know where to start plotting your parabola, tells you where the axis of symmetry is, and tells you which way it's opening, and basically how wide it's opening. Now, you have to plug in a few points, but it tells you a lot more information than this does. Tons more information. The A is the same. That tells you whether it's opening up or down and how wide or narrow. But the B and C tell you nothing useful. H and K tell you very useful stuff. So here's why this is a standard form. This form is especially convenient for sketching parabola, a parabola, because it identifies the vertex, HK, and that's it right there. They don't mention this. It also tells you the axis of symmetry, x equal h. That gives you exactly that. And it tells you the A part, whether it's opening up or down, and basically how wide. So, the quadratic function in this form, f of x equal A, now what you have to do is factor out that A, x minus h squared plus k. Now again, just like before, A cannot be 0. Why can A not be 0? There will not be a parabola, because if A is 0, all you have is f of x equal k, that's a constant. That's all it is. That's not a parabola. So A just can't be 0. That's in standard form. The graph of f is a parabola whose axis is the vertical line, like I said before, x equal h. I mean, just get used to writing that down. Whose vertex is the point hk, k, and when A is positive, it's going upward. When it's negative, it's going down. When A is a very small number, it's a wide parabola. When A is a fairly large number, it's a skinny parabola. Okay? Vertical stretch or shrink. Okay. So those 3 parameters tell you a lot of useful information. Every one of them does. Okay. So to graph a parabola, if you're given an equation for the parabola, to graph it, it's helpful to begin by writing the quadratic function, not in the good old ax squared plus bx plus c form, but in standard form, using the process of completing the square, Oh, you thought you were through with this when you got the quadratic formula, didn't you? Nope, it's coming back. Okay, that's how we got the quadratic formula, by the way. So we'll do that in example 2. In that example, notice that when completing the square, you may be adding and subtracting something to inside and outside parentheses, whatever, okay? And what that something is the square of half of the coefficient of x. What? We'll get there. Within the parentheses, instead of adding the value to each side of the equation, okay? So we'll be adding or subtracting on the same side. So we don't change the formula any. Okay. Here it is. Sketch the graph of f of x equal 2x squared plus 8x plus 7. If I just told you that, can you just jot it down? Probably not. I can't. Okay, if you can, okay, never mind. All right. Then we'll identify the vertex and the axis of the parabola. Okay, we can do that. How do you reckon we're going to proceed? What's the first step? Any ideas? Give me some idea. Okay, you will be doing that. The book says to, right? What you're trying to do is get it in standard form, which is going to be something like a times what? X minus h squared plus k. Got it. That's what we're gunning for. To make it look like this, that one doesn't quite look like this. Now, what's the first thing it appears you got to do? Factor out the 2, because you see, this is the same a as that a, okay? And you need to get it outside parentheses, and you're only interested in the x terms. You don't care about that constant. You're going to fiddle with that later. So factor it out of the x terms. So that's your first step. So the first step would be factor out the 2 of the first 2 terms. What does that leave you with? X squared plus 4x blank plus 7. Why is that obnoxious blank in there? So you can do the next step, okay? Now that's the same as what we have there, isn't it? It's just got a big space there. But otherwise it's exactly the same, right? We haven't changed it at all, have we? All right, now what we've got to do now is take whatever is in here and make it a square of a binomial. Right? Oh, because we want it in here. See, the x's are out here with the a, the x is all in there. We want all the x's in the parentheses. Okay, and what we're going to do is try to make this a perfect square trinomial. Remember that? That would be that form. Now, let's go up to that form. What would be x minus h squared? You tell me how to do that. There's one of 2 ways, either by the rule or actually for it. I don't care which one you do, which one you want to do. I want to know what x minus h squared is. Second? X plus 2, is that what you said? Okay, no, use x plus h and square it. Okay, it'll have an x squared minus 2hx plus x squared. Okay? Oh, no, plus h squared. What am I doing? Y'all are leading me astray, aren't you? Okay. I erased the wrong thing. Okay. Let's go back and see what we just did. Okay? What I think Amber was doing was squaring the first term, right? Twice the product of the 2 terms, and squaring the last term. And minus h times minus h is plus h squared. See, you still got me messed up. Okay. Okay, never mind. Got it. Does everybody see that's what it is? Okay. So, if this is that, what do we need to do to make this that? Well, just looking at this, the x squared is the same. That's why we factored out the a, by the way. So it would look the same. Okay, now we see here that minus 2h must be plus 4. Right? Okay, so let's write that down. Minus 2h equals 4. You buy that? Because that's the coefficient of the x. What does that make h have to be? Divide by negative 2. Okay, and that would be h equal negative 2. So we know what h is. Okay? But then what's the next part? You square it. And what happens if you square negative 2? Plus 4. You just changed the problem, folks. And here's how you change the problem. Justin came in. That's how you changed it. Okay. All right. What you have done, you just sort of added 4 here, but not just 4. It's 2 times 4. You added 8. So what did you better do over here? You better subtract 8. Well, if you added 8 here by adding the 4 in there, if you do a minus 8 here, you haven't changed the problem. You added 8, but then you subtracted 8. And that's what they were talking about before. You add and subtract the same thing to the same side rather than adding the same thing to both sides. So that's the same form, right? Now, let me make it a little easier for you, I think, than doing all that. Here's the rule. Take half of the linear coefficient of x. Half of 4 is 2, and then square. There you have it. That's all you have to do. You don't have to go through that, but that's what we did. We took half of this 4 and then squared. That's how you got the plus 4. All right. Now, and by the way, as soon as you do that, go on and write this down. 2 times x, okay? Half of 4 is 2. Write it down there, 2. Square that, and then what do we have over here? No, over here. Negative 1. So I put the wrong sign, didn't I? You let me get away with that, okay? Minus 1. Okay? Do you think we have anything that looks like the standard form? What can you tell me? A is equal to 2. H is equal to negative 2, because that's a minus h, that's a plus 2, so h has to be the opposite of that, right? Because minus a minus 2 is a plus 4. And k is equal to negative 1. Hey, look at there, folks. We basically have what we need to sketch the graph. So let me draw the axis. Okay? I'll tick off a few points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9. Positive 1. Ooh, that's not high enough. 2, 3, 4, 5, 6, 7, 8, 9. Negative 1, 2, 3. Okay. You tell me how to begin. Where would you start? Negative 2, negative 1. How do I find that point? Say again? Left 2, down 1. Right there. What do we call that point? The vertex. It says identify the vertex. The vertex is negative 2, negative 1. Got it. Okay? Now, it says the axis of the parabola. What do you reckon that is? Yes, x equal negative 2. And we say it that way, x equal negative 2. Okay? They usually do it in red, so I'm going to do it in red. Okay? There's your axis of symmetry. Okay? Let's go back to dark. Dark. Okay. Now, we've got the vertex, we've got the axis of symmetry. Now, where do you go from here? Okay. Actually here, I'm going to do something that is a bit, the book doesn't tell you to do it, but there's no reason not to. Let's go back to that first form that we were throwing out and saying it was worthless. It wasn't quite. Okay? Because one thing here does give you one little piece of information. Anyone think what that might be? And x equals 0, what is y? X equals 0, 0, 7. That's still your y-intercept. So your y is equal to 7. So 0, 7 is on this. So how do you get to 0, 7? Go up 7. 1, 2, 3, 4, 5, 6, 7. 0, 7 is on that graph. And guess what? The axis of symmetry comes to the rescue here. Because you go to the axis of symmetry, how many places do you have to go? How many? 2. So you go 2 more over here, and you have another point. What's that? Negative 4, 7. Also is going to be on that graph. Okay? Okay, that gives us two more points. Okay? Axis of symmetry is so nice to have. All right, now here's what I like to do. You don't have to do it this way, but it's how I like to do it. Let's pick me an x either just to the right or just to the left of your vertex. Vertex is x equal to negative 2, so let's choose either negative 1 or negative 3. I don't care which. Which one you want to use? Second? Negative 3. She likes to use negative 3. So let's put a negative 3 in for x. Okay, I'm going to write it down as an ordered pair. X is negative 3. We're going to calculate the y, the f of x. Okay? If you put a negative 3 in here, what do you, negative 3 plus 2 is? Negative 1 squared is? Times 2 is? Minus 1 is? 1. Okay? So that's going to be negative 3, 1. So let's go over here to negative 3 and go up 1. And now, because we see our axis of symmetry, what can we do? Go to the right, and that'll be 1, 2. That's why I said use either one of them. I don't care. Okay? Now, your next one that we would have done was go either left or right 2. But we've already done that. If you go left 2, you go to 0. That gives you 7. Yeah, we've already done that. Okay? Now, if you wanted to, you could do another one, but you would be off scale. Okay? So this is all I can graph on this piece of graph paper I have here. Here is your, there it is. Okay, the negative 4. Oh. Over here? Right.
No, we did negative 2, negative 2. We went up 7 and then went over 4.
Okay, got it. Okay. I said, what happens if you put a 0 in here? I go back to the original because it's so much easier. X equals 0, y is equal to 7, all right? So 0, 7 is up here, all right? Now, what we mean by an axis of symmetry, whatever is happening over here has to be happening over here. So since this is 2 to the left here, go 2 to the right. 2 to the right here, go to the left here, and you got another point on that graph. Just like down here, you got this one and that. If you went up with another one, you have whatever that and that. They're going to be the same because parabola are symmetric about that line x equal h. So use it. You know, don't work too hard. Yeah.
Okay, I don't see how you simplify x squared plus 4.
What?
I don't see how you simplify x squared plus 4x plus 4.
How you got from this to that?
Right.
Okay. All right. Here's what you do. Same. Okay. Let's. What the rule was here, how we got that 2 in the first place, is take half of 4. Half of plus 4 is plus 2. And then you square it. Okay. Now that's a perfect square trinomial. The first one's a perfect square. The last is a perfect square, and the middle is twice the product of the two. This is the square of x, that's the square of 2. Twice the product of those two is 4x. Okay? That's how you went from there to there. Now, let's go the other way. Let's do x plus 2 times x plus 2. Okay? For it, what do you get? X squared plus 2x plus 2x plus 4, and that gives you x squared plus 4x plus 4, right? So that's gave you that, which means it had to be this. Now, notice what you did here. You squared the first, you squared the last, and you had twice the product between the two because those were the same. So how you go from here to there, take the square root of this, the square root of that, and half the product of this, and square that. And that will give you the 2 that you need. Because if you just take the square root of that, you can get plus or minus 2. Taking half of this, you guarantee to be plus 2. Yeah. All right. And Brianna's here, right? Okay. You're missing Natalie, Jeremy, Anna, and Shay. Okay. Sorry. Now, I said this before. A few people have come in since then. Let me say it again. My office hours today are somewhat shortened because I've got to go to the Birmingham campus and pick up a van for a field trip this afternoon. So my office hours today will be around 12-ish to 12:30, and that's all in the middle part of the day. Okay? I may be back before 12, but not much before. Catch me, start looking for me a little before 12, should be back. So if you want to either take your test or finish your test, that's the only time I've got available today. Except for the fact that after the field trip, and I hope to be back here between 3:45 and 4, we'll be back, and that class will be taking their final exam then. So you're welcome to come, say around 4-ish or so, a little before 4, around 4. And if there's room in the class, you can take your test then. If there's not room in the class, I'll find another classroom for you. And they won't be on, their final is going to be really short, okay? So they'll be through probably 15 to 30 minutes after the field trip. So after that, I'll be back in my office until 5:15. So if you can't catch me right around 4 while they're taking the test, sometime after that, check me in my office. I'll be there, but I have to leave today by 5:15. So if you haven't done it yet, do it then. Now, if you can't do it today and want to do it tomorrow, remember tomorrow I'm on the Birmingham campus. So if you don't tell me you want to finish your test or take your test, I won't have it over there. I don't haul them around just in case someone shows up. So let me know if you're planning to come Friday. But tomorrow. But remember, I've got a physical tomorrow, so I probably won't be there before 9:45 or 10 o'clock. But I will be there then. So if you do want to take it between, say, 10 and 1, I'll be over there. But let me know you want me to take your test, because I'll put it in my grade book and take it with me. Okay? All right. We just finished sketching the graph. We identified the vertex already, and we identified the axis of the parabola, also called the axis of symmetry. It's whatever your h is, x equal h, always. All right, let's clear this out of the way and see while they do it. Begin by writing the quadratic function in standard form. Notice that the first step in completing the square is to factor out any coefficient of x squared that is not 1. Okay? The coefficient was 2, that's not 1, so factor it out only of the x terms, the 2 terms with x's in them, not the constant term. So the next step would then be to factor out the 2 from the x squared plus 8, 2x squared plus 8x. That would give you 2 times x squared plus 4x. Now, I like to leave a big blank there so you can go on to the next part. Okay? Leave the plus 7 on the outside. I like to have the blank there. Why? What's the next step? You tell me. take half of the 4, the linear terms, half of 4 is 2, and then square it. That will be 2 squared is 4. But because you added 4, you added 8 because it's 2 times that. That's still in parentheses. You added 8, then you'll subtract 8. So that's what they do next. They take half of the linear term, half of 4 is 2, square it and you get 4 again. But then because you added 4 here, you got to subtract 4. Now I don't like to do it on the inside. That doesn't make any sense. I like to do it on the outside. But you have to remember that that's a minus, that you got a 2 in front. That's why they put it on the inside. So it's 2 times 4. I like to do the minus 8. They do it this way, which is perfectly fine. Yes, we did. We subtracted 8. We did, yeah, right? That's 2 times 4. They put it on the inside, so you put 4 minus 4 if it's on the inside. Okay? After adding and subtracting 4 within parentheses, you must now regroup the terms to form a perfect square trinomial, which would be that part. That leaves you a minus 8 that you put on the outside. So it's just an extra step. And frankly, to me, the way they word it, it makes it a confusing step. But that's what they do. The minus 4 can be removed. 2 times minus 4 is taken out of the parentheses and put out here with the plus 7. Yeah, if you see that better, do it that way, okay? To me, it's a little extra work, and I'm lazy, so I don't like to do it, but do it whatever way you see best, okay? And then, when you do that, you now have 2 times x squared plus 4x plus 4. That's your completed square. And then minus 8 plus 7. I had a plus 7 minus 8. It doesn't matter, okay? Now, this, by definition, because you're doing half of this and squared it, that guarantees to be a perfect square trinomial. So now you factor that into what is the binomial square. And frankly, as soon as you take half of this, write it down there, because that's always what it is. Half of this is what goes in here, put it in parentheses and put the square on. Okay? 2 times this, and then this adds to minus 1. Okay? I'm just showing you the shortcuts, but this is the perfect square of that. Okay? So, now we've written it in standard form. From that form, you can see that the graph of f is a parabola because it's a quadratic function. Okay? We knew that already. Opening upward, how do we know that? The coefficient A is positive, absolutely. Has a vertex where? Okay, remember, anything to do with the x is always backwards. So that's a plus 2 here, so the vertex is minus 2. Anything to do with the y is the same, minus 1. Just remember that. X's are backwards, so you always change something. Okay, so it's minus 2, minus 1. Okay, so we got the vertex. We know it's opening upward. We also know the axis of symmetry is x equals negative 2. So put that in. Okay, notice the sum thing. Okay, good. All right. Now from here, you've already got 1 point. They didn't show you the other easy point. To me, why not? Okay, go back to that original form, put x equals 0. You get automatic that last term, that c is your vertical, is your y-intercept. Why don't they show you that? I don't know. Not in this form, but in the original form. So easy to do. Okay, and then anything you got left of to the right of this, you're going to have the same thing to the left. So since that was at 0, 7, then at negative 4, 7. It's going to be across the line of symmetry, the axis of symmetry. Okay? Now, the rest of it is plotting. And why go back to that point? You can, perfectly fine. You want to go back and plot y is equal to x squared rather than y is equal to this. Just translate that down here and move it down. The 2 is a non-rigid thing, so that's why they have to put it here. But then the translation is rigid, so just move it there. Frankly, I found that not that easy to do. So what I do is pick a point somewhere to the right or left of negative 2. That would be either negative 1 or positive 1. Negative 1 or negative 3. One to the right or left here. Plug it in here. See what your y value is. You got it to be plus 1, both of those. You got it here, but then you go across the axis of symmetry to get it there. Use the axis of symmetry. Don't do calculations twice. Do it once and then use the axis of symmetry. We already had the 7 go across the axis of symmetry, and you have a negative 4, 7. Okay, it's just automatic almost. Okay, and you can keep doing up if you got enough graph paper. Does that make sense? Okay. So let's move on. Oh, okay, there's still figure 2. In the figure, you can see that the axis of the parabola is the vertical line passing through the vertex, which is x equal negative 2. That's why it's always, since the axis of symmetry always goes through the vertex, the value for x is always negative 2. X equal negative 2 all up and down the horizontal line. Okay? Any y value, don't do that. Okay? Okay, so now you've done everything they ask you. All right, now, to find the x-intercepts of the graph of that, what is the x-intercepts? What is an x-intercept? Where it crosses the x-axis, and what's true about anywhere it's on the x-axis. The ordered pair of every point on the x-axis has what in common? The y is always 0. What's your y? Okay, it's 0. But in function notation, what's your y? F of x. So if you're looking for the x-intercept, that's where y is equal to 0, just set that equal to 0. Now that one we want it in quadratic, standard form for a quadratic equation. We like that form, because what can we do with that? One of two things. Actually, more than two things, but usually we do one of two things. If it's factorable, you factor. If it's not factorable, you use a quadratic form. Okay? That's it. Once you have that, this thing equals 0. That's why we call it standard form for a quadratic equation. That will give you your 2 x-intercepts. If you have 2. You may have no x-intercepts. Occasionally, you only have 1 x-intercept. Most of the time, you have either 2 or 9. Occasionally, a 1. Now, if this thing does not factor, then use quadratic formula. So you answer your question was right here. Find the x-intercept. Remember, however, a parabola may not have x-intercept, or it may only have 1. Okay? What determines that? If you use the quadratic formula, what determines whether you have any x-intercepts or only 1 x-intercept? Okay, do you remember what the quadratic formula is? Maybe that's what I should ask first. If you have this form, you can write down the answer. X equal what? Minus b plus or minus the square root of b squared minus 4ac all over 2a. You got it. Very good. Okay, now what determines whether you have any x-intercepts, only 1 x-intercept, or 2 x-intercepts? The what?
The direction is opening and its vertical shift.
Okay, that, yeah, graphically that is. Using just this, what do we use? Anyone remember? What's this thing here called? That's the discriminant. That discriminates whether you have 1 solution, 2 solutions, or no solutions. What that is. What will this have to be if you have 2 solutions? 2 real solutions. No, it has to be positive. Now, if it's a perfect square, that means you have 2 rational solutions. 3 halves and negative 4 halves, or something like that. Okay. If this is positive, this thing in here, then you can take the square root of it, and you'll have 2 solutions. Right? Whether they're radical solution, if this is a perfect square in here, then you'll have 2 rational solutions. If it's not a perfect square, you have 2 real solutions. But what if that's not possible? Well, there are two options then. It's not positive, you have two options. What would it be? Not positive. It's either going to be negative or 0. So what if this thing's 0? Then you don't have 2. The plus or minus 0 doesn't fit. Here is your solution. You have one and only one intercept, and that's minus v over 2a. That's it, folks. That's all there is. Minus v over 2a. One and only one x-intercept. Okay? And what if this thing is negative? Say again? No intercept at all. So if the discriminant, the thing inside the radical, is positive, you have two real solutions. If it's negative, you have no real solutions. If it's exactly 0, you have one and only one real solution. Okay? So that's what determines that from your quadratic formula. Now, if it was factorable, your factors are going to tell you your zeros. Okay? What's that? Okay. Okay. Just a little bit of review, right? No extra charge. Okay. What's that? Oh, no. Okay. Let's see. That was standard form for a quadratic thing. We've already done example 2. By the way, there is a checkpoint. It was for example 1. There is also for example 2. Use your checkpoints. Okay? Now, I think we're ready for example 3. The trouble is they don't do example 3 or 4. So let's us do example 3 and then maybe 4 also. We'll see what we can get done. Example 3. Sketch the graph of f of x is equal to, there it is, minus x squared plus 6x minus 8. Okay? Sketch the graph of that. Now, since you're here, and you know we're going to come back and do it anyway, you want to go and get an easy point? Say easy point? 0, negative 8. You know that's on it. So I'm going to write it over here, 0, negative 8. We've already got 1 point on that graph. Okay. Doesn't do us a lot of good yet, but it will later. Okay. Then what do we do? Factor what? You got to factor out the minus 1, or just the minus sign. What does that leave you for your x terms? X squared minus 6x, very good, blank, minus 8. Okay, you like my blanks, don't you? They're 3 syllables long. Okay, never mind. Okay, now what? Okay. All right. How do we make that a perfect square trinomial? You what? Okay, take half of the negative 6, which is negative 3, square it, and you get plus 9. Now, I like to go on and start my next line because as soon as I ask you what's half of negative 6, and you say negative 3, write it down. You already know what that part is already. You don't have to go back and think about it. You know what it is. That's it. Okay? But now let's go back and see what we did. What do we do here? We just subtracted 9 from that. You added a negative 9 here. You added 9 there, but you had a minus sign in front, so that was actually minus 9. What had you better do here? Add 9. Very good. Okay? Now, you already got this part done, and what do you have over here? Plus 1. Okay? Can you tell me anything else now? Your vertex, which is another point, is 3, 1. All right. Okay. Because remember, this is dealing with the x, so it's always opposite. So that's dealing with y, so it's the same. Okay. 3, 1. We got 2 points already. Yes?
Okay, so the 3 wasn't negative because of deleting the negative outside the parentheses.
Okay. This 3 here? Or that, yeah.
Or it was positive
Right, okay.
because of the symmetry, not because of the negative outside the parentheses.
Okay. The reason that 3 is positive, that's what you're asking, is because this is x minus h. Remember, that's the standard form. If you need to do that, write that down first. We did it before. Standard form is a times x minus h squared plus k. So whatever the sign is in front of here, whatever sign this have, it's going to be the opposite there. Whatever sign that is, it's going to be the same there. Because it's always x minus h. Because you always deal with the x's go with opposite signs. You know, if this is minus 3, that becomes a plus 3. Now, I thought maybe you're asking how did that become a negative 3? That's because you had a of negative 1 here. You had to factor that out, so that plus 6 became a minus 6 here. Okay, and then when you take half of that, it's a minus 3. Write it down in the square. And then when you,
How do you derive into that?
what's that?
How do you just go from like negative 6 and you said you're just gonna square it? Because I'm thinking, okay, that's 9, right? Is that what that is?
You mean from this right here?
Right. So,
Okay.
but I'm just saying, how did you get the 3?
This 3 here.
Yeah.
Okay. Okay.
Half
of negative
half the
6.
negative 6. Why
Yeah.
did you have it?
Because that's how you get a perfect square trinomial. Okay? Going back to
Going
this.
back to the formula.
Going back to the formula. Okay? Because the perfect square trinomial is the square of this twice the product here and the square of that. So if you're going the other way, you start with half of this because you did twice that to get it. Take half of this, and that's what you square here, and you already know what you square there. Okay? You're just doing it in reverse. Okay? All right. Does that answer it? Okay. But remember how if we are squaring this, remember that rule? Square the first, twice the product of the 2, that gave you, the product is negative 3x, you double that, negative 6x. And then you square the last. Well, since you're going the other way, you have to take half of this, because you doubled it before, take half of it down, that's how you know what that number is. That's where it comes from. Okay. You already got 1 point, and I guarantee you're going to be able to get another point out of that. You got the vertex, fantastic. You've got the parabola in standard form now. With that, the vertex, tell me what the axis of symmetry is. I'm going to do this in red because we did it before in red. Okay, the AOS, axis of symmetry, is what? Yuck. Is what? X equal 3. Why did I put a parenthesis there? I have no idea. Okay, X equal 3. Whatever the H is, but X equal that. That's your axis of symmetry. Say again? Don't put it 0. You already got 3, 1 is the thing. Axis of symmetry is a line. A vertical line is X equal H, A, whatever. That's how you name a vertical line. You have to put an equal sign in there. Horizontal line would be Y is equal to 7 or something like that. Vertical line is X equals something. Okay? So, what did it ask us to do? This is number 3. Sketch the graph of this. Identify the vertex and the x-intercepts. We haven't done that. How do we get the x-intercepts? How do we get the x-intercepts? Say again? That gives you the y-intercept. We already did that. How do you get the x-intercept? What's true about an x-intercept? Where are x-intercepts located? It's over on the x-axis. What's true about every point on the x-axis? Every point on there. Y is equal to 0. What's your y? What's your y? You gotta know that answer. F of x. So put that equals 0. So this will get the x-intercepts. Set that equals 0. Now what do we do with that? Go back to the original to do the x-intercepts. Okay. Actually, before I factor, I don't like leading off with a negative. So I'm going to multiply everything on both sides of this equation by minus 1. That'll make that a plus. That'll make that a plus. And it makes this a negative. Okay? And it makes 0, 0. Okay. So that was a sleight of hand, but it's legal in most states. Okay? Now what do? Factor, if possible. You may not be able to factor, but does this factor? What's the only possible factorization for x squared? X times x minus 4 minus 2. So what does that give you as your x-intercepts? X equal 4, x equal 2. And what did we say the y's were? 0. So this is 4. I can't write. 4, 0, 2, 0. Okay? We got 2 more points, folks. Okay? It's ugly, isn't it? I can tell Ashlyn doesn't like my ugly writing. Okay. Could you? Okay. All right. We got 2 more points. 4, 0, and 2, 0. Okay? I think we got enough to start graphing, don't we? Okay? I'm real tempted. I think I will. Is to use this line here as my horizontal axis. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3, 4, 5, 6, 7, 8. Positive 1, 2, 3, 4. Negative 1, 2, 4, 5, 6, 7, 8. Whoo! Just barely made it. All right. Where do we begin? 0, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, boy, just made it. Where else do we do? 4, 0. 1, 2, 3, 4. 4, 0. 2, 0. Okay. Where else? 3, 1. 1, 2, 3, 1. Oh, that's looking pretty good, isn't it, folks? Okay, next. What else do we know? One more thing. Say again. Yes, x equal 3 is our axis of symmetry. Okay, so that's... Okay, now, what did you say? 6, negative 8, because you saw this point was 3 to the left of the axis of symmetry. 3 to the right would be here, and that would be a negative 8. If I could draw it somewhere down here. Okay, I think that's about right. Yeah, it looks on even. Looks like we can get one more point in there. Which one would you choose? Either x equal 1 or x equal 5. Which one you want to use? 1, okay. So up here we'll have when x equal 1, f of 1 would then be minus, and what's 1 minus 3? Negative 4 squared is? Oh, okay, wait, say that again. Negative 1. No, that's not a negative 1, it's a plus 1, sorry. 1 minus 3 is? Negative 2 squared is? Plus 1. Okay, so this will be negative 4 plus 1, which is negative 3. Okay, so 1, negative 3. 1 minus 3, right there. And where else can we go? Use the axis of symmetry. 5, negative 3. Very good. All right, now draw your curve. There it is, folks. Right there. Does that make sense? What are you missing? Okay, how do you eat a 5,000-pound elephant? One bite at a time. Just do the things they ask you to do. Real easy to get the y-intercept. We did that right off the top. Now, remember, we changed the signs here, so I shouldn't have done it there. And maybe while we're there, we should have gone and got the x-intercepts. We could have. We got those two. Okay? completing the square, we got in standard form, which gave you the vertex. Once you know the vertex, x equals h, that's going to give you axis of symmetry. All that stuff is chop, chop, chop. It's just pretty straightforward. The only thing a little different is picking out some more points, and pick a point that you want to see. Okay, you got those other points up there. X equals 1, let's see what that is. Plug it in, and you get wherever that was, -3. And then you use axis of symmetry to get on the other side. Probably right. Okay? Now, unfortunately, we ran out of time. I know that's the worst news you've heard all day. But we're going to start next time on example 4. Okay? I have all sorts. That's on page 118. Okay? But the good news is you got some homework exercises. I would say do all of 7 through 12, but the odd number answers are in the back, 7 through 11. Okay? Do either 13 or 15, whichever you choose. Any of the odds 17 to 33. I think you can do any of the odds 35 to 42. And maybe we'll stop there and pick up the rest of those later. Okay? Gives you plenty of stuff to play with this weekend. Should be a fun weekend then too, won't it? Yes. Use your checkpoints. Use the, now there's 2 different sites. The checkpoints are at LarsonPrecalculus.com. Your homework exercises are at calccheck.com. Use both of those sites to help keep you up. Frankly, folks, when I was grading the test, what you've done of them so far, I got the distinct impression maybe you're not using these things very well, and maybe you're not doing the homework very consistently, and I even got the suspicion you weren't even bringing in formula and equation sheets for your test. I don't know why. I kept telling you to do all 3 of those, so please get caught up. Try to get your test done this week or next week. Yeah. What's that? I can't hear.
Finish my test today.
To now, right now? Fantastic.
Want me to stay here?
No, I'll have a class in here. I think next door is open though. You too? Okay. Let me shut this down. Yes, sir.
I've had baseball games.
Oh, yeah, likely story. Okay.
Maybe I can take mine next week.
Yeah. When next week?
Wednesday or Thursday.
Wednesday or Thursday.
Tuesday.
Okay.
I got to finish my mini turn.
Yeah. Wednesday, my office hours are basically 3:15 to 5:15. And Thursday, next week, my office hours change. I forgot to tell you that. So Wednesday is 3:15 to 5:15. And Thursday, my office hours change next week to be 10:45 to 1:15. Tuesday and Thursday, 10:45 to 1:15. So a few more office hours on Tuesday and Thursday. All right, good deal. Okay, y'all are ready? Let me shut this down.